As we're designing and building a robot, it's for a different challenge every year, and we have to operate within certain constraints. This year, for example, we have an 84-inch height limit, and we have to fit our entire robot within a 54-inch cylinder, so we have some size restraints. There's also a weight constraint that we have to make sure our robot's under, so we can't do anything too big or too bulky. It also forces us to use different materials. We can't build it out of steel, even though that would be a lot stronger, for example. It has to be out of lighter materials, so we have to really keep in mind our materials and then the different sizes and way we're going to approach different challenges based on those constraints.
I'm Andrew, and I am a programmer on our robotics team. The programming language that we use is Java, and we store our Java programming in a repository called Bitbucket, and we use that to store it on all of our computers. Basically, what we do is we program the robot to do all of its tasks during the competition, and we use the driver station, which has a couple of joysticks attached to it to control the robot.
I'm part of the chairman's group, so this year we decided to go for the Chairman's Award, which is a prestigious award that can get you to nationals. So a little bit of what you have to do to do the Chairman's is a lot of outreach, just put yourself out there and create a presentation to present to the judges along with a bunch of documentation about your team and what you've done over the years.
The Chairman's Award is an award that goes through all aspects of our team, spreading FIRST message in the mentorship that we have with other teams. It's not just how good our robot is, but how good the other aspects of our team is. Along with FRC, we have two other robotics activities in St. Peter. We also have an FLL team, which is First Lego League, which is a little Lego robot that you program autonomously to go out and do missions on a board. And then there's also the First Tech Challenge team, which is a bigger robot that you have a little bit of autonomous part, and then you can drive around yourself and you compete with other teams.
For the whole match, there's 2 minutes and 15 seconds. The first 15 seconds are autonomous, where your robot has already been programmed to do this. So for our autonomous, our robot drives over and jumps frisbees into the lower goal to score points. After the initial 15 seconds, there's 2 minutes of person-operated time, where you have your drivers operate the robot. During this time, our robot goes and climbs the pyramid. Our goal for that is to get a 30-point climb or climb all the way to the top. But currently, we can only get a 20-point climb because our robot hangs too low. We're currently working on fixing that. Our robot drives well. The robot actuates. The climber design tips forward to orient itself with the pyramid.